Tell all your friends to come. How's everyone doing today? All right, that's great. Ooh, this actually sounds kind of loud. So is everyone ready to learn how to program music? All right, cool. So normally when people go to a conference, they have to justify to their employer why they need to go to a conference. And this is kind of a different sort of presentation. I'm not going to teach you anything useful for your job, at least not directly useful. But what I can say is that doing something like this will help you with creativity and thinking outside the box. So you can use that excuse with your employers now and for the future. But really, I'm learning something, even if it is music. So thanks for having me here. Thank you to Stir Trek and all the sponsors. This is my presentation, Sonic Pi, programming music for fun and profit. Lots of profit, tons of profit. So hi, I'm a live coder. My name is Scott, and I work for a company based in Madison, Wisconsin called Fradkin. I am a consultant. I'm a team lead and Java and JavaScript developer. So that's what I do during the day. After work, I do fun things like teach community education programs. I like to teach kids programming. And I also partner with a local company, and we do Sonic Pi workshops for kids in underserved areas of the community. So this is a lot of fun. I love talking about Sonic Pi, and I hope you all enjoy this as well. And I'm also a live coder, and we'll get into that in a little bit. So how in the world did I get into this? Well, it's kind of a weird thing because I have no music background. I'm not a musician, but I've always been a big music listener, and I can remember way back in the old days buying lots and lots of music on cassette tape, and then over the years graduated through all the different music formats. And then and now I listen to tons and tons of music. I'm always listening to music, probably like many of you do, programming away with headphones on. I did have a year's worth of cello in elementary school. I don't know if that counts. Maybe it does. And the obligatory semester of music theory in college, which is actually a good class, but I remember none of it. So that has no bearing on any of the work that I do right now. But I do remember being interested throughout in creating and messing around with music, even if I really had no music background to begin with. And some of you may remember the old days with trackers in the demo scene. So back in those old days, and maybe I'm dating myself here, I did actually create a few tracks with Impulse Tracker. That was a lot of fun, but the tracks were predictably rather horrible, and hopefully they are lost in the great bit bucket in the sky. Although I wouldn't put it past anyone to try to unearth something that I created and then post it for me. But I never really did anything creative with music since then. So fast forward many, many years into the future, and my wife and I got one of our kids an electric guitar. I'm like, cool, now we have an electric guitar in the house. So that really kind of piqued my interest in getting back into some sort of creative music mode. So by coincidence, I went to the Strange Loop conference in 2014, and there just happened to be a presentation where some crazy guy from the UK named Sam Aaron talked about this music program called Sonic Pi. I was interested. After the conference, I downloaded it, played around with it a little bit, and I was like, this is cool. I'm a programmer. I like programming, and I like music, and I want to create music, and this really combines both of those together really wonderfully. So I just kind of went with it, and I got really interested in Sonic Pi. I got interested in another language called Tidal Cycles. I started working with web audio in the browser to create music as well. And there's a whole live coding community. There's a Slack and a bunch of message boards as well. And just started getting real into that. So live coding is cool, but what is it anyway? So I define live coding as programming in an environment where what I'm coding is executing at the same time, and I can easily modify my code, re-execute the code, and have those changes applied immediately or almost immediately, so I can see and hear what my modifications have done. And when you apply this to music, you get into a really nice flow of music and change and modifying things a little bit at a time and hearing the change that you've coded yourself. It doesn't just apply to music. There are a number of individuals who live code visuals as well, and usually in accompaniment with music, so crazy glitchy graphics and different designs and things, but it's all live coded on the fly. You can even apply this conceptually to educational settings. Some of you may know the Scratch programming language that kids use to graphically learn how to program block-based and graphically. So as one of my side projects, I'm creating a block-based live coding language, not using Scratch, but using a JavaScript clone of Scratch. So from an educational perspective, live coding also comes in really handy because kids can change stuff around, re-execute their code, and immediately hear and see a difference. So I know that in the abstract, I tossed in there something about rave. And so what is algo rave? Algo rave isn't heard too much in the United States. But what it is, it's a logical extension of live coding. You have a number of individuals who live code music and visuals in a group setting, just kind of like a bunch of bands or DJs playing a show. And it's called an algo rave because you have people creating algorithms that are generating the music you hear and the visuals that you see. Ooh, let's see. So the whole scene, live coding and algo rave, has been around since about the early 2000s. It really originated in the UK and in Europe. And as the years have gone by, there have become more and more live coding languages and environments available. And the use of these have really expanded really worldwide. Over the past few years, a lot of people here in the United States have really gotten into it. But you're here to learn about Sonic Pi. So the brief history of Sonic Pi. So this guy up here, you can see him over there. He's got a shirt on that says programmer. That is Sam Aaron. He works at the University of Cambridge in the UK. And he is one of the committers for a project called Overtone. I don't expect anyone's ever heard of Overtone, but what it is a Clojure-based live coding language. It runs in Emacs, and it's Lisp-based because Clojure is Lisp-based. And behind the scenes, it uses the Super Collider synthesis engine to create the sounds that you hear. And it's actually a really cool language, and it's really low level and really powerful, but it's really hard to set up. And if you're not used to Lisp, it's really, really hard to get into. So Sam, as part of his research, really wanted to come up with something that was more accessible, especially to kids. And so he created Sonic Pi off of that idea. So I wanted to, before we get into showing you Sonic Pi and how to do stuff, this is the environment that Sonic Pi gives you. It's a self-contained IDE, and it has everything in it that you need to work with Sonic Pi. There's nothing else to install. It's a single app for Mac. It is a single application for Raspberry Pi. There's now a Linux package for it, a Debian-based package. And Windows actually has an MSI installer or a self-contained exe. So this is my awesome artwork. As you can tell, I am not an artist. But I wanted to kind of give you a visual of kind of all the intricacies that are in Sonic Pi here. So it looks like a single application, but it's really 3 different distinct parts under the covers. And each part communicates via open sound control messages. It's just a text-based protocol, and it's abbreviated OSC. So we have the GUI, which you see in this slide. And that GUI is a C++ Qt application. The server itself is all written in Ruby. And then that little SC on the end is Super Collider. So again, just like Overtone, it uses Super Collider to do sound synthesis. Yeah. So the language that you use is Ruby. It's a DSL written in Ruby. You don't have to use Ruby, the full language spec of Ruby, but you can if you want to, if you really want to get creative with the code. Let's see. So we take a little pause. So most of the rest of this is just kind of demoing to you all the basics of Sonic Pi and how to actually create music in Sonic Pi. I want to leave a little bit of time to kind of show you how I go about live coding some music, so you get to hear a little bit of what I like to do, and maybe it'll sound horrible to you, maybe you'll like it. I usually generally like it since I'm the one creating it. And then after that, I'll have a little bit of kind of tidying up afterwards. So you can download it at sonic-pi.net. Unfortunately, you probably can't, unless you're tethering your phone, you probably can't do that here. So all right, we'll switch over to Sonic Pi. So I'll put all this out on my GitHub. All of these sample files, I've got a whole mess of notes in here that will help you later when you look at it, if the video is not available yet of this presentation. So the first thing we see is, here's your environment. The main window is where you're going to type in code. On the right-hand side of the screen is a cool little debug window, and I'll expand that a little bit more, maybe, so we can see it. There we go. So as you're running your code, this displays to you timestamps and exactly what's going on at any given point in time. So you can start looking at the code and seeing what's happening in the debug window and hear it all at the same time. Along the bottom is the help bar. And this has had a tremendous amount of work put into it. There is a full tutorial, so please feel free to check out that tutorial. It's probably written a lot better than what you'll hear. And it contains a lot of articles that Sam writes for the Magpie magazine. And every release, he adds new articles to the Sonic Pi package, so all the new articles get in there as well. It has a large number of song examples that Sam and others have written. And there's full documentation for all of the synths, effects, samples that are built into Sonic Pi, and a full language reference. So it's really, really comprehensive, and I'm constantly referring to it, and I'll probably look at it while I show you stuff here. At the top, we have a run button, a stop button, and a record button. So run obviously plays what we've written. Stop will stop everything. And record will record what's playing to a WAV file, so you can archive audio for yourself. And then you can save and load files up at the top. There are little buttons that say buffer on there, and that gives you 10 windows of buffers that auto-save to the hard drive for you. So you can kind of put a bunch of stuff in there, shut down Sonic Pi, it'll still be there the next time you open the program. So let's see, let's start out. All right. So the most basic command we have is play, and play simply plays a note. So I'll type in play 60. Oh, and we hear there we go, that's nice and loud. That's a nice tone. We look on the right-hand side, it says, hey, at time 0 you played synth beep with note 60. Cool, I like this. I can play note 65, it sounds higher. I'll play note 55 and sounds lower. So if you're reading my notes up there, the numbers are actually MIDI notes. MIDI is a sound communication standard for hardware and software that was created umpteen million years ago, and it's still around. It works very well. You usually use it to communicate with hardware, synths, and things like that. The notes go from 0 to 127, at least in the MIDI spec. And yeah, but they're kind of useless unless you've memorized what those notes are. All you kind of know is that lower numbers are lower frequency notes and higher numbers are higher frequency notes. I mean, you can do some cool things with Sonic Pi. You can give it fractional notes, and it works fine. Might not necessarily be musical, though. But what's more useful here is we can say something like play :C4. So let's just use the standard Ruby symbols, and we can say play a C note, and the number afterwards is the octave number. So when I say play C4, it's going to actually play MIDI note 60 behind the scenes. So you can, just mess around. That's a really low note. Probably have to turn up the volume to be able to hear that. You can do sharps and flats. To do a sharp, you just do a S after the note. Ooh, boy. And I can even do a flat with a B. All right, cool. So now we know notes. So the play command has a lot of different options with it. And actually, what I want to do is need a comma before the options. And Sonic Pi will automatically bring up some code complete for you. So you can see there's a few options by default. These are the options that are always available to you, no matter what kind of synth you're using. So amp is a standard amplitude. So if I want to make it louder, I could do amp 2. 1 is default. So that's really loud. I probably don't want to do that. And the next most commonly asked question for me is, how do we make different length notes? So without getting into more details, and there's actually a pretty decent explanation in the tutorial about it, Sonic Pi supports a standard ADSR envelope for playing stuff on the synths. And if we change the release value, we can make the notes longer or shorter. So if the default's 1, if I say release 2, ooh, that's a nice long note, and I can do a really short note. Let's say 0.1. Boop. Cool. So there's other options. Again, they're all documented, but those are really the most commonly used ones. How do we make things louder and softer, and how do we make notes shorter and longer? So that's notes. So Sonic Pi built in has a large number of samples. And to play a sample, we simply type in sample. And then again, it gives us a really nice autocomplete. And this has gotten to be a pretty large list at this point. So I can type in, my favorite, house bass drum. And usually we got to make that a little louder. Cool, bass drum, awesome. It also has a number of options that you can attach to playing the sample. Amp is one of them. And there's lots of built-in samples for drums, ambient sounds, a lot of percussion, a number of loops. There's sample, here's a good one, ambi-choir. That's always fun. So I like to, if you know classic drum breaks, they obviously have to include the Ambient drum break, which sounds like this. Yes. So a fun thing to do with samples is change the rate. So if I want to make it twice as fast, I say rate 2. Ooh, fast, fast, fast. I can make it half as fast by saying rate 0.5. So nice and slow there. You can even do fun stuff, and you can get into some really, really neat sounding things by doing this. Negative numbers. Plays it backwards. So that's always a lot of fun to play with. You can layer multiple invocations of a sample, play one backwards, slightly offset. It can sound pretty cool. All right. So I have two notes. I'm going to play C4. I'm going to play a D4. So I can't really play an actual melody without being able to play notes in sequence. So all right, I type in play C4, play D4. Well, I'm not sure that's quite what I wanted to happen, and we can verify what happened by taking a look at our debug pane, which tells me at time 0, it played 2 notes at the same time. Thank you, Sonic Pi. That's not quite what I was after. But Sonic Pi, without, we have a little communication going here, brain to computer. It's like, well, you didn't tell me to do anything else. So in order to put some space in there, I have to use the sleep function. So I can say sleep 1. And now I have the second note playing at time 1. And you can do longer, shorter, whatever you want. Cool. So one thing that's not immediately obvious is these numbers that we use for sleep, that's not actually a time. It's a number of beats. And the number of beats is dependent upon the tempo that Sonic Pi is currently running at. By default, if you don't tell it any kind of tempo, it's going to run at 60 beats per minute. And so because it's going at 60 beats per minute, a sleep 1, it's a 1-beat rest. By default, all the notes also run for 1 beat. So if we want to change the tempo, we can say use BPM, and maybe I want to run this at 120 beats per minute. So that's twice as fast as 60, and looking at our debug output, we can verify that. So our sleep 1, which is really 1 beat, not 1 second, makes it so that the time that second note was invoked is at time half a second. And you'll also notice that the amount of time that the note plays for was also changed. Sonic Pi internally appended a release of 0.5 to each of those notes. So Sonic Pi is pretty smart under the covers, and it figures out that when you change the tempo, it has to change the length of notes and the length of your sleeps. So it makes it a lot easier for us as programmers programming the audio to only think about beats rather than seconds, because I don't want to really think about something like 73. Maybe I really want to do something at 73 beats per minute. I'm not going to remember that I have to have my notes go for 0.8219 seconds and have a spacing like that. That's not what I can remember. All right, different tempos. Yes, use BPM. I put that in there. Okay, so here's some cool stuff. So I have that A-man loop sample, and I want to loop it around multiple times so we get a good drum beat going. So I can use standard Ruby number.times to loop things multiple times. I'm going to do sample loop amen, and if I can type, there's a function called sample duration, which will figure out for me how long a sample goes for, because I don't know how long that amen loop sample goes for. And the only way that I can loop it multiple times and have it sound seamless is if I tell Sonic Pi to sleep for exactly the right amount of time after that sample plays. So this figures it out for me. Yeah. So you can see that the time that it's invoking subsequent plays of the sample, 1.7533. Yeah, I had no idea that's how long that sample is. So Sonic Pi does that for me. But an even easier thing to do, if you have a sample, let's say I wanted to use the amen break as the backing drum track for something that I'm doing. I can actually tell Sonic Pi to take this sample and use that as the basis for the tempo of Sonic Pi. So now I can simply do a sleep 1, because by default it will assume that I want to equate the length of that sample to a single beat. And so it calculated the correct amount of time there. But it's a little bit more useful than that, because that sounds like a good 4 beats worth of stuff there. So I can ask Sonic Pi instead to actually equate that sample to 4 beats of music. Now that does mean, because my sample is now 4 beats, I have to sleep for 4 beats after I play the sample, otherwise it won't work correctly. And that number of beats can be anything. If you want the length of that sample to equate to 50 beats or whatever, you can do that as well. Sonic Pi is not going to stop you. All right, let's see. So cool, we can play single notes, we can sleep, we can play some samples, we can manipulate some other things. And now we need things to be a little bit more useful. So generally in music, we play music in chords, perhaps. So Sonic Pi has a chord function. And we can easily play this by saying play chord, and you tell it what note to start the chord at. And then it gives you a whole bunch of options. These are all of the different chord types that you can use, and there's quite a lot of them. So I'm just going to do a C4 major chord. That sounds great. So it figures out for us that if you take a look at the debug pane, and maybe this, can everyone see that okay? I can make that a little bigger. It tells us that that C4 major chord is note 60, 64, and 67. And it's got this word ring on there, which I'll get to in a minute here. So that's cool, but it only grabbed me 3 notes. Well, what if I want a bigger sounding chord? Well, I can say num octaves 3. That sounds so much nicer. And now we can see that list of notes that it's playing has grown. So the number of octaves tells it to keep going up octaves and pick out all of the notes on those octaves that make up this chord. Cool, that's actually really helpful. So one thing we can do here is, instead of play, we can do something like, let me just copy and paste to make my life a little easier here. I can store it in a variable, and then I'll print it out so we can see what that does. So you didn't hear anything because I didn't tell it to play anything. But that chord function actually returns a value, and we stored it in the variable r. And I asked, and this is just a Ruby put s, to print it out to the screen. So we can see over there, it says ring 60, 64, 67, and so on. And those are the same notes that we played before. So that's going to come in handy in a little bit here. So scales are similar. So maybe we want, actually they're so similar, I'm just going to copy this. I say play, and I can replace this with scale, and I'm just going to take out num octaves here. So brace yourselves a bit. This might be a little jarring. So that sounded horrible, right? That's because we don't generally play all the notes in the scale at the same time. So you can see it picked out all the notes in a C major scale. or starting from C4. So that's not incredibly useful to play all at once like a chord is. Chords are meant to sound good. Scales are just a sequence of notes. But again, you can use the scale function to generate a bunch of notes in a scale and store it in a variable for later use, which comes right now. So let's grab this again. And we'll just define that here. So I have this. Now, so you recall that it creates a ring. Chord and scale create rings. And all a ring is a circular array. So what that means is that we can index into a ring at any index. If you go past the end of the ring, it'll go all the way around and start back at the beginning. So if I have a ring with 3 notes in it, and I say, give me the 4th note, it'll actually go back and give me the first note in the ring instead, which is really, really cool and really, really helpful because that allows us to do things like, let's change this to 1 octave just so we can see this a little easier. And I can do 6 times do, and I'm going to say play r.tick. And actually going to say, I'm going to change the release to something short and have a short amount of sleep in there so that we can hear it. So cool. We have a ring that we created with 3 notes, and we have a loop that plays 6 times, and you just heard 6 notes, and it played the notes in order, and it wrapped around and went back to the beginning and played all those notes in order again, all because of this tick function. So what does tick do? Tick is just a counter. It's a counter function. It starts at 0. And every time you call tick, it returns the previous value and increments the counter. So the first time through the loop, the value is 0. The next time 1, so on and so forth, every time we call tick. Cool. That lets us do some interesting things. Sometimes what you really want to do is share a tick counter. So we could do something like call the tick function by itself, and then instead of calling tick on our ring R, we call look instead. And it should sound exactly the same. And fortunately it does. And so tick increments our counter for us, and look just looks at the current value of that counter. So now we can have multiple rings, and we can use the same counter for multiple rings. Tick also allows you to pass in a key, so it can keep track of multiple independent tick counters in your code that you're executing. All right, cool. So I'm going to change this back to 3 octaves, so we have 3 octaves worth of notes. And I'm going to take out tick. And I'm going to replace that with the function choose. Choose sounds pretty straightforward, and it really is. Choose can operate on a ring or a plain old Ruby array, whichever you might have at your disposal. Cool. So it picks out random notes from your ring or array. Now, I'll play this once more and take a close listen. Okay, anyone notice what happened? It's exactly the same, that's correct. So choose uses the random number generator behind the scenes, and when Sonic Pi boots up, it grabs a random seed. But the problem is that that seed number never changes. So every time you execute your code, it'll just keep choosing the same random numbers every single time. So to get around this problem, there is a function called useRandomSeed. And you just feed it some random integer. And I pick something else. And that gets me a little more randomness if I change the seed. Now you may have a long-running music process, in which case it'll just keep picking random numbers from an unchanging seed. But generally, you're re-executing code over and over again, and you might want to just periodically change that seed so that you get a little bit of differentiation going on. And I think, is that what I have? Yep, okay, that's all I wanted to talk about there. Okay. All right. So one thing you may have noticed is that it keeps using this synth called beep. Beep is fantastic. It's great. It sounds so nice. Such a nice sound. But it gets kind of old after a while. You know, there's only so many songs that you can use beep with. So what we can do is use this function called useSynth. And SonicPy kindly gives us some autocomplete here, and we can choose something. Let's use the detuned saw, and now it sounds different. That's great. I can play one note with that synth. If I type in use synth again and I choose something different, how about growl? And I'll play, let's do an E. Now, of course, so I always forget to put sleep in here. Bear with me. Okay, cool. So we can use synth operates for everything underneath it. If you call useSynth again, it will change the synth that's used for the next set of code that's underneath that. But there's an easier way to encapsulate things, and that is by using with synth. So if we use with synth, and I'll use dsaw again, this is actually in block form. So say play C4, sleep 1, play E4. Cool. So now we've scoped where we're going to use our specific synth to an actual code block. So it becomes a little bit more manageable to actually see what's being used for what pieces of code at any given time. All right. So I'm going to go ahead and copy that. And I think we're doing just fine on time here. All right. So we have a synth. And I'm going to change these to play a little bit longer. How about 3 seconds, or 3 beats? Oop, yeah, there we go. So we have a release 3, and this sounds like so. And they overlap because I only put in a sleep of 1. So it'll start playing the second note before it finishes playing the first note, and that's perfectly fine for what we want to do. So effects. So notes sound great on their own, but sometimes we want to spiffy them up a bit, have some fun with it. So we use a function called withFX, and we can see a bunch of things. Oh, let's see, what do we want to use today? Let's do, oh, reverb is so nice. Let's do a slicer. So again, it's just a block. And if I could type end, that would be great. And we run it. So that's pretty cool. So each effect has a whole mess of different parameters. We can actually take a look at that. So slicer. Oh, we can play with the phase and the pulse width. So why don't we do phase, do 0.2. You say pulse width, default value. You probably can't, oh, you can kind of read that there. I thought it might be too small. It starts at 0.5. We'll change that to 0.75 and see what happens. Ooh. So that's pretty neat. So the cool thing about effects, when you think about, if any of you work with DAWs or any other kind of music creation software, you can chain effects, right? You can do a whole mess of things to your audio all at the same time. And you can do something similar with SonicPy. So I'm just going to say with effects again. And let's add some reverb. Again, it makes it easier if I can type correctly. So all I do is just add another block. So I'm just putting blocks within blocks within blocks. And we can bump that up to 1. Sounds a little bit different. We already get some pretty good sound in here, so I'm not sure that, yeah, you can kind of hear it right at the end there a little bit better. You can do more. You can keep chaining things until your computer breaks, really. Super Collider is extremely efficient under the covers. If you're running this on a laptop, you're probably not going to run into any issues. If you're running it on an older Raspberry Pi, you're going to run into limits. There's only so much you can make those old Raspberry Pis do at a time. So it gets a little fuzzier. That's going for a really long time, too. Holy moly. Let's stop that. All right. Okay. All right. So that's synths and FX, and both of them have a lot of options. And there are some common options between everything, but each one does have its own options, and there's just too many to remember. It's easier to just check out the documentation. So, all right. So what we haven't talked about is, all right, cool. We've got some code. We can make some music. But from an organizational standpoint, how do I rig this up so that I can do things like play a drum beat and then play some notes at the same time? Well, there's 2 different ways to do that. And the first way is to use this function called inThread. And this is more useful for creating compositions because it's a fairly static kind of thing. So when we use inThread, it's a block of code that will run in its own thread. And we have to name is optional. I always recommend that you give your threads a name. So we'll say drums. And it's a block, so we need a do and an end. And I am simply going to do a little loop, do my awesome house drum, and I'm going to say sleep 0.5. All right, so now we have our basic house drum beat. The debug pane tells me exactly what thread is running. So you can see that I'm playing this BD house sample in the drum thread, which can be really helpful. So maybe at the same time, I want to create some melody. And maybe that requires me to create a ring. So I'm going to say R equals chord. Well, let's do like a D3 chord. Minor this time. Num octaves 3. I like 3. That's a good amount of notes. And we'll say r.tick. And, well, or play r.tick, because that might be a little more helpful. And we'll change the release to 0.25, and we'll sleep for 0.25. Cool. All right. So the end result of this should be, if I coded it correctly, and we'll see in a moment, is that we'll hear drums and some notes all at the same time. And actually, we need a loop there too, don't we? So let's do 8 times. Good thing I caught that. That would have been extremely disappointing for everyone. Cool. Just goes up through the notes. All right, so that's inThread. So the combination of using inThread to run multiple threads of code at the same time, and there's also a define function, which I haven't showed you, but define allows you to define functions within Sonic Pi. And you can do a Ruby define to define a function. It's def, D-E-F. but it's highly recommended that you actually use the Sonic Pi version of defining a function, because that will make the function get all of the Sonic Pi goodness under the covers. The code is open source, and you can go check it out. But there's a lot of crazy code behind the scenes that deals with threads and timing and making sure everything works correctly. But the combination of defining functions and using in thread to kind of create a composition is extremely powerful. Now I'm going to go ahead and copy all this. And we'll comment that out. And let's show you live loops. So this is the second way to run multiple things at the same time. All right, so instead of in thread, we say live loop. We don't need to say name colon, but we do have to give it a name, because a live loop is just a thread that's running, and it needs a name. So we'll type that in, do that. All right. So one other aspect of live loops is that a live loop will run indefinitely. It won't stop unless there's a syntax error, which will kill a live loop. There is a stop function. If you just put stop anywhere in the live loop, it will stop that live loop from running. Or you could hit the stop button up top or press the key combination to do that. Otherwise, live loop will keep going. Because of that, we can take out these loops here. We don't need those anymore, because it's already going to loop for us. Sometimes you want those in there if you want to adhere to some kind of timing and you want to know that a specific live loop is always going to play like 16 beats worth of music. But if you're not too concerned about that, you can just take out any other loops and just let it loop for you. And it just keeps going on and on and on until I stop it. Okay, cool. Well, that's great. So one of the cool things about live loops, and I'll show you, the actual live coding in a moment. It allows you to change stuff on the fly, and then all you have to do is rerun the code, and Sonic Pi will automatically redefine the functions behind the scenes, and then insert that new code into the runtime, and you'll hear the change in the music. So let me do that for you. So I'm just changing the release and the sleep so we get slightly longer notes. I hit Command R to reevaluate it, and we heard the change. So obviously that was a very simplistic change, but it shows you what it can do. So one thing you'll notice when you work with live loops is if you do a lot of changes in the length of the loop, either by changing the lengths of your notes or changing the lengths of the sleeps between notes that you play, eventually your loops will get out of sync. And that's kind of a bad thing, right? It's good to have things in sync. So what we can do, and there's a handy way to do this, we can tell one live loop to please sync with another one. So here I'm telling the melody loop to please sync with the drums loop, and you just use those names. So if we play this, this is kind of a bad example, but so if you saw what happened, let's see here. Okay. So in the yellow up there, we can see that it says sync drums. And the thread name on that is live loop melody. So that's telling Sonic Pi that the melody loop needs to sync with the drum loop. So every live loop, at the top of the loop, it emits a cue event. And that gets printed out there in the pink highlighting. It says cue drums. The next section down there says synced drums, and then cue melody. So that's the melody loop. It's essentially just a wait. So the thread's just waiting, and it's waiting until it hears the cue event from the loop that it's syncing to. So you notice that everything was in sync then, but that will always keep it in sync. And if it ever gets out of time, that melody loop will wait for a cue from the drum loop before it starts running again. So that can be really handy if it gets out of time. One other cool thing you can do is add a delay. So maybe I want to delay by 1 1/4 beats. So now I'm saying, actually I'm going to take out the sync drums, but yeah, there we go. Now I'm telling the melody loop, okay, delay by 1 1/4 beats before you start. And that's exactly what happened. It's a little bit hard to see here, but right here is the first time that I highlighted there. That is the first time that the melody loop ran, and that's at time 1 1/4, since we're running at 60 beats per minute. So let's see how much time we have. Oh, we've got some time here. So that's all the basics, really. We could go on and on, but it might be better to just kind of show a little demo here. So we put together things by live coding. You know, we can do a bass line, a drum track, a melody, and do some embellishments and effects. And I can do all this in real time, on the fly, out of my brain, directly to the computer, to your ears. And I'll do this for a couple minutes and we'll see what happens. I don't know. It's a high pressure environment. Mess it up. This is the beauty of live coding. And if you mess it up, you just go with the flow, right? It doesn't sound like the album. No, it doesn't, does it? All right. All right, let's try this first. All right. What else should we add here? I love the suggestions. That's good. You're gonna make me laugh too much. I'm not even gonna be able to do this. Oh, last cowbell? All right. See how that sounds. Oh, pan slicer, what can I do with you? I know I can have some fun. That's not doing what I expected. See the fun of live coding? I can't tell. Maybe it's not in stereo. Ooh, that's good. This is pretty cool. All right. Oh, no. That was so sad. So we'll go ahead and stop that. Read about on. On is really fun, and spread function is phenomenal to play with as well. All right. So I actually have a couple more slides here. Sonic Pi basics. We did some live coding. Cool. So that's how you live code. Yeah, it is. So cool thing is everyone has a different style of music that they like to create. I typically do a lot of experimental stuff, some straight up techno if I feel like it. Everybody has a different style of programming. So I might code things one way, and you might code things a completely different way, and it'll sound extremely similar. But that's part of the fun. The cool thing is that the more you practice, the more you begin to equate your code with the music that you hear, and vice versa. You can start to kind of think about the kind of music you want to create and just kind of know what code to type in to make it happen. The most important thing about live coding, have a good sense of humility and have a lot of fun, because you'll probably mess it up one or more times. So Sonic Pi is really cool stuff, and part of what I like about Sonic Pi is that it's accessible to kids of all ages and differing experience levels of programming. So it's extremely easy to learn how to program using something like Sonic Pi because it doesn't really feel like you're programming. Kids really, really dig this. The workshops I do, they're 3-hour workshops, and I never hear any complaints from kids that it's too long. They love it, and some kids really like the fact that they're learning how to program, and some kids just really dig the music, and kind of backhandedly, they're learning how to program at the same time. So it's really a lot of fun. Let's see, what else do I want to go through? So you can learn Sonic Pi. You can have a lot of fun with it. You can write an album with it. Make some money off writing an album. You can go play clubs. I know multiple people who use Sonic Pi in algo raves. But what I'm asking you to do is, if you really dig Sonic Pi and you think it's a lot of fun, share it with some kids. Get kids coding and creating rather than consuming things. So I have a slide after this that I'll put up with a number of resource links. This will all be up on my website, fradkin.com. I think I can do a pull request to get it added to the StirTrek repo as well. Come say hi to me. I'm talking at that conference in August, Midwest JS, and ICLC, which will be a tremendous amount of fun. ICLC is the International Conference on Live Coding. So I'm actually presenting a short paper there and doing a Sonic Pi workshop. So that should be a huge blast. So thank you for coming to my presentation.